Welcome back to segment number 2, which has to do with measurements in chemistry. Chemistry is a very quantitative science, so we really need to know how to uh, report data and also how to work with data values in terms of mathematical operations. So the first thing is, how do we describe numbers in chemistry? Well, there are exact and inexact measurements, or exact numbers and inexact numbers, which are measurements. So an exact number is something that is commonly known. So 12 eggs is a dozen, 3 feet is a yard, 12 inches is a foot, and so on. So those are your exact measurements, values that are commonly known for quarts in a gallon. So when you work with those values, you just use them as is, and you don't worry about how you report the number of places that the number has. So that's what we're going to talk about a lot. So an inexact number is something that you measure, and it depends upon the precision of the instrument will tell us how many digits we use as we report the number. Okay, so we're going to be able to consider things like equipment error and human error when we consider our inexact measurements. All right, so first thing, just to describe the difference between precision and accuracy. I know there's something in one of the videos, one of the helpful video links, that describes the difference between the two. And, precision is how close individual measurements are to each other, while accuracy is how close you are to the true value. And so they use this nice dartboard example to describe the difference between accuracy and precision. And so when we talk about precision, we really want to look at how we write a number. So if I were to write this number in scientific notation, 1.03 times 10 to the fourth, or if I were to write it with 1.030 and then an extra zero here. So what does this mean? This tells me that, well, first of all, this number has 3 significant figures. All 3 of those numbers are significant. So if I put a decimal point in, everything that follows becomes significant. And so now here I have even greater precision because I've added another 0 and increasing precision as I move to this written value. So one thing I'll tell you right now, because we will be looking at a lot of numbers that are written in scientific notation. When you consider scientific notation, or when you have a number written in scientific notation, you only count this number out front. In mathematics, it's called the mantissa, and this is called the exponent. So what this tells me something about the instrument that I've used. It means that that instrument is precise, and it's precise out to that last, just before that last 0. So that last 0 is what we call the estimated value. That's the one that we're not sure of. But we include it to tell the person that's reading your data that there is a degree of uncertainty to this point, but your certain value would be from this point back. So I'll explain a little bit more about this as we go. So now we need to know how to count significant figures. And so what we know is that from my example that I just used, that zeros seem to be the big placeholder for significant figures or not. So we talk about significant figures. These are the 4 rules. I'm not going to read them to you. I'll show you a number of examples here as we move forward. So let's take a look at this. So those are the 4 rules for sig figs. How do you identify a zero that's significant or not? And one thing to always keep in mind is that non-zero digits are always significant. So anything that's a non-zero, we always call that position as significant. And I will just use as an abbreviation from this point forward, sig fig. So if I look at this example here, sorry, these examples that I have here, let's try it. So here's 2 non-zero digits. Those are definitely significant. So now any zeros that come before the non-zero digits are not significant. So this example here has only 2 significant figures. Now you don't want to get rid of those zeros. It doesn't mean you can get rid of those zeros. It just means that when I'm doing a mathematical operation later, we'll talk about that, I'm going to know that I would consider this to be 2 sig figs. Now I go to this here, 1, 0, 8. 2 non-zero digits, the 1 and the 8, those are both significant. The 0 in between is also significant. So anytime a 0 comes between 2 significant numbers, that 0 itself is significant. So there's 3 there. Now, the minute I put a decimal point, this example here, the minute I put a decimal point in, everything beyond it becomes significant, and everything before it becomes significant because I have this non-zero digit out in front. So this example would have 4. So these examples here, well, when I say these, I mean anything that looks like this, you're going to have non-zero digits on the ends, so everything in between becomes significant. I always think of it as the sandwich rule. Anything in between the 2 slices of bread on the end is going to become significant. So this example would have 5. Right. The next example, this one's a lot like the example up here. So these zeros are not significant, so I would not count those. There's a non-zero, there's a non-zero, there's a 0 in between. Now I have a 0 that follows. So any 0 that follows a non-zero digit and follows a decimal point becomes significant. So that would mean this example here has 4 significant figures. Now we move on to this one. There's 3 because you have your 2 non-zeros and a 0 that follows a non-zero digit and a decimal point. Okay, so I go to this example here, and that's going to show 4 significant figures. Right, so that's how you count your sig figs. I have loads of practice of that for you, and in the content shell, and I'll do some more examples with you as I get to the end of these slides. And then rounding is, all of the rules are here, to make it as simple as I can for you. If I have a value that's something like this, 4.45, and I could only report, if I needed to report this in, let's say, 2 sig figs, then I would have to round it up to 4.5. And if I had, if my value were this, 4.44, and I had to report my answer in 2 sig figs, then I would report my answer as 4.4. So that's really the easiest way to think about rounding. I'm going to stop there for now, and I'll be back.